Okay, we are solving by factoring. Exact same rules as before. The only difference is there's a 2 in front. Right? If you have a number in front of your x squared, we're going to do the method of borrow and pay back or bottoms up. Just depends on what your teacher calls it. Okay, so here's what that means. We are going to multiply that 2 with the last number in the problem. All right, so this is going to become x squared plus 11x plus 30. All right, so all we did was we multiplied that last number by 2. Okay, from here, we are going to factor. Remember, we are looking for two numbers that multiply together to get the last number. We are multiplying to get 30. Multiply to get 30. So I need numbers that multiply to get 30. Well, 1 and 30, 3 and 10, 5 and 6, 2 and 15. Lots of different numbers. Okay, one of those combinations needs to add or subtract to get 11. All right, so 1 and 30 does not get 11. Okay, 3 and 10, it could get you 13, but not 11. Okay, 2 and 15, again, or could get you 13, but not 11. 5 and 6 is the combination I need. X plus 5, x plus 6. All right, but don't forget what we did earlier. All right, in the very beginning on this problem, we borrowed that 2. Okay, we multiplied this number by 2. So if we did that, we then need to pay back. Okay, again, here's what that means. All that means, if we multiplied by 2 to pay it back, we're going to divide both answers by 2. So if you multiplied by 2 in the beginning, you're going to divide by 2 at the end. And just like before, you are setting these things equal to 0 to solve. So I can't reduce 5 over 2, so I'm just going to leave it. 6 over 2, that's 3. And I'm going to solve both of these problems. Okay, so for this one, all I need to do is subtract 5 halves from both sides. So x equals negative 5 over 2. Done. This one, same thing. We're going to subtract 3 from both sides. X equals negative 3. Solving by factoring. On this one, we are simplifying this complex number. Okay, it's called complex because it has a number and an I with it. To simplify this, it's a little bit long, but it's not hard. All right, if I want to get, what I want to have happen is I do not want I to be in the bottom of a fraction. All right, so to get rid of it, what I'm going to do is I'm going to multiply the top and the bottom by the conjugate. Okay, and all that we mean by conjugate is we want to change the sign of whatever's on bottom. So if it says 5 minus I, the conjugate is 5 plus I. All right, if the problem was, I don't know, 3 over 2 plus 2I. Okay, if that was the problem, then we would want to multiply by 2 minus 2I on top and bottom. Okay, whatever the bottom is, multiply that on top and bottom with the opposite sign in between. All right, so that's what we're going to do. We're going to take these two things and multiply them. So I need to take this and multiply them together. Okay, so I'm going to take 2 plus 2I times 5 plus I. These two things and multiply them together. All right, and then I'm going to do the same thing with the bottom. On the bottom, I'm going to take 5 minus I times 5 plus I. And I'm going to multiply that out. So this becomes just a multiplication problem down here. All right, so down here at the bottom, I'm going to do this work. So I'm going to multiply these two things together. So just like we did earlier, 2 times 5 is 10. 2 times I is 2I. And then we're going to multiply the second thing here. So the 2I. 2I times 5 is 10I. And 2I times I times I would be 2I squared. We can simplify. Combine those two things together. 12 plus 10, or 2 plus 10 will get me 12. All right, and then this is an important thing right here. All right, I squared. When you see I squared, okay, I squared, anytime we see I squared, we are going to replace it with the number negative 1. Okay, so when you see 2i squared right here, that's the same thing as 2 times negative 1. Anytime we see I squared, we're putting a negative 1 in its spot. So if it's 2 times negative 1, that's really minus 2. And then I can finish this problem. 10 minus 2 gets 10 minus 2 gets me 8 plus 12i. All right, so that is the top, because we did 2 plus 2i and 5 plus I. We multiplied them together, and this is what we got. So that's going to go on the top of my fraction, 8 plus 12i. All right, then we got to do the other one. We're going to multiply it together. Okay, so here we're going to take 5 times 5. It's 25. 5 times I is a positive 5i. The next thing we're going to do is take that one times that one. Negative I times 5 is a negative 5i. Right? And then negative I times I is negative I squared. So here's the key. The reason we multiply by the conjugate, okay, the reason that we switch from 5 minus I to 5 plus I is because when you multiply these two things together, the middle term is going to cancel always. I've got a positive 5i and a negative 5i that is going to cancel. So I get 25 minus, hey, look what we got here. We've got an I squared. Remember, when we see I squared, we're plugging negative 1 in its spot. So it's minus negative 1. Well, if it's minus a negative, that's really plus 1, which gets me 26. So that's what I got on bottom. When I took this times this, I got 26. So 26 is going to go on bottom. Hey, we're almost done. Can I reduce all three things by a number? Yep, I can reduce them all by 2. So let's do that. So 8 divided by 2 is 4. 12 divided by 2 is 6i. And 26 divided by 2 is 13. There's my answer. So again, the key, multiply by the conjugate. Whatever's on bottom, change the sign, multiply that on top and bottom. I don't care what that top is when I'm talking about conjugate. I just want to know what's that bottom. 5 minus I, okay, I'm going to multiply by 5 plus I on top and bottom. Then it's just a matter of doing the work and plugging it in. Number 6, we've done this problem a ton now. Hey, I've got a minus sign. In front of parentheses, change all the signs. So I see that minus sign. Let's change some signs. So change, change, change. So my problem becomes 4 minus 2i plus 2 minus 6i. That wasn't hard at all. All I did was change the signs. Now I'm going to combine like terms. 4 and 2 gets me 6. Negative 2i and a negative 6i. Negative 2 minus 6 is negative 8i. Done. All we had to do was change the signs when we had a negative in front of the parentheses and combine like terms. Here, we're solving. Again, we should be good at this by now. All right, x squared, all I want to do is solve. Add 9 to both sides. 49, x squared equals 9. All right, I'm not allowed to get rid of the x squared yet before I do exponents. Okay, I tell my students when we're solving Pemdas in reverse. I'm trying to get x by itself. I'm doing Pemdas in reverse. The first thing we did was we tried to add or subtract. We did that. We added 9. Then I need to multiply or divide. So I want to get rid of this 49 right here. Right now it's being multiplied. So to get rid of it, I'm going to divide. After I've divided, it doesn't work out evenly, so I just left it. But to get rid of, so I have x squared equals 9 over 49. Now I want to get rid of exponents. All right, I have an exponent here. I've got that square. So if I want to get rid of that square, I need to square root both sides. That cancels. I can do this. The square root of 9 is 3. The square root of 49 is 7. But don't forget, anytime we take a square root, it's going to be plus or minus. Remember, in the beginning, I had a square. That means I'm going to have two answers to this problem. Every single problem on this test should have two answers when we're doing solving. There's my final answer. Number 8 should be easy. If you can do number 5 on the front side, where we had to simplify with the conjugate, this one's twice as easy. You don't have to do anything besides multiplying. All right, so all we're going to do is go through our multiplication steps here. 2 times 1 is 2. 2 times negative I is negative 2i. 5i times 1 is 5i. And 5i times negative I is negative 5i squared. Now we're simplifying. 2. Combine those two things together, so negative 2i plus 5i would be a positive 3i. Hey, look what we got here. I squared. Anytime we see I squared, we're going to replace it with negative 1. So if it's negative 5 times negative 1, it's positive 5. Then I can finish by combining like terms. 2 plus 5 is 7 plus 3i. We're doing a quadratic formula problem again, so we should be good at this. We did one in the other part as well. Where it says use quadratic formula, so I know I'm doing this. It's an x squared problem, so I know I'm going to get two answers. First thing I always want to do is label what's my a, what's my b, and what's my c. Remember, whatever's in front of your x squared is your a, so it's 1. Whatever's in front of your x is your b. And whatever's tagged on the end is your c, whatever number's there. Then we're going to plug into this formula. So it says negative b. So that's negative negative 5 or positive 5. Plus or minus the square root. Square root b squared. So that's negative 5 squared. Anytime I take a negative number and I square it, it's going to be positive. I guess I should write that out. So that way we don't get confused. Let me do that again real quick. Sorry. So b squared. So negative 5 squared minus 4 times a times c all over 2 times a. Once we've set it up, remember where we head to next. Now we're going to look underneath the square root sign. That's what we're doing next. I'm going to come right over here to the side and do that part. So negative 5 squared is 25 minus 4 times 1 times 5. 4 times 1 is 4 times 5 is 20. 25 minus 20 is 5. Remember, that's square rooted. All right, if we could simplify that radical, we would. Okay, if I knew what the square root of 5 is not perfect. I can't break it down at all. So all it is square root of 5. So let's plug this back in. 5 plus or minus. I know what that is now. It's that. Square root of 5 all over 2. There's no simplifying I can do in this problem. There's my answer. Don't make it harder than it actually is. We plugged in and we simplified as much as we could, but there wasn't a whole lot to do. Last one we're solving. So we look at the problem. We're trying to solve for x. All right? It's an x squared problem, so I know I'm going to have two answers. Anytime I'm solving for x, I want to think I'm doing Pemdas in reverse. So when I look at this problem, the first thing I want to do is add or subtract. So the first thing I want to do here is subtract 7. 2. A negative 11 minus 7 is negative 18. We added or subtracted. Next thing we want to do is we want to multiply or divide. Well, I can do that. I have this 2 in front. It's being multiplied. Do not distribute that. That is the number one mistake students make. Instead, I want to divide. I want to get rid of it. Right now it's being multiplied. To get rid of it, I divide. Now it's gone. X minus 4 squared equals negative 18 divided by 2 is negative 9. Now I can deal with exponents. To get rid of exponent, I've got a 2 right here. To get rid of it, I'm going to square root both sides. That's the opposite of squaring. So I'm left with x minus 4, and then I got to take the square root of negative 9. Remember, the square root of 9 is plus or minus, because it was squared. I knew I was going to have two answers, plus or minus 3. But since there was a negative underneath that square root, it's going to be 3i. Remember, anytime we take the square root of a negative, it's 3i. Then to finish this problem, all I need to do is add 4. Okay, get rid of that last thing. My answer, x equals plus or minus 3i plus 4. You can't combine those two things because one has an I and one doesn't. This is an awkward answer. All right, that's okay. You'll probably accept it, but we always put the number first. So my real answer here would be x equals 4 plus or minus 3i. That's what you'll see as your final answer. Notice that that is two answers. Okay, it was squared. The plus or minus signified two different answers there. A little bit weird, but not awful.